Hi everyone, today we are going to start chapter 10. 10.1 is use properties of tangents, and our goal is to use properties of tangents to a circle. A circle. A circle is the set of all points in a plane that are equidistant from a given point called the center. If we look at our example here, we have a red circle. We notice this point right in the middle. That is the center. Now we have the letter P right next to it, so we can name that center P. Center of a circle. The point inside the circle that is the same distance from every point on the circle. And a circle is named by its center point. So it can be either called circle P, or you can write it where you have a circle with a dot in the middle. We know that that means circle. A radius. A radius is the distance from the center of the circle to any point on the circle. If we look down here, we see it's that red line from the center to the outside of the circle. A chord. A chord is a segment whose endpoints are on the circle. Once again, if you look at our example here, it is this green line. So the difference between a radius and a chord is that the radius goes from the center to the outside. A chord just goes from one point on the outside of the circle to another point. It does not go through the center. And then a diameter is a chord that contains the center of the circle. So diameter here is blue, and it goes through the center. A secant line is a line that intersects a circle in 2 points. So once again, look down here. We have a secant line, and a line goes on forever and ever. That's where those arrowheads come from, and it just goes through 2 points on the circle. And finally, a tangent line. A tangent line intersects a circle in exactly 1 point, and this point is called the point of tangency. So if we look at this blue line here, we see that it only hits the circle at 1 point. That's called the point of tangency. And since there's a B next to that point, we call that point of tangency point B. And it's a line, and it goes on forever and ever and ever. Tangent lines do not go through the circle. Anytime it goes through the circle, it would be a secant. All right, so tell whether the line, ray, or segment is best described as a radius, chord, diameter, or tangent of circle C. So let's look at AC. AC is right here. What is the best way to describe that? Well, it would be a radius. Next, let's look at AB. All right, well, AB would be this entire segment here. What would be the best way to describe that segment? Well, it would be a diameter. Okay. Ray DE, so DE here. What would be the best way to describe that ray? And it would be a tangent. Why? It doesn't go through the circle, and it only hits the circle in 1 point. And then finally, AE. AE is this line right here, and that goes through the circle. It's a line that goes through the circle, so it is a secant. Next, what word best describes segment AG? So if I were looking at, and we don't have arrowheads, that's why I know it's the segment. So we're just talking about from here to here. And since it's not a line, it's a segment, we know that this would be a chord. How about CB, segment CB? So we go from here to here and we stop. What would that be called? It would be a radius. Next, we want to name a tangent. Now we already named a tangent in the first part, ray DE, so we don't want to reuse that tangent, but we could call this tangent BE. So a tangent would be BE. And we want to call it a line. We could also say BD and make sure we use a line. And then it's asking for a tangent segment, which we could use the same letters here, except for call them segments this time. So BE, and just put a line without arrowheads, and then BD. And don't put arrowheads. Coplanar circles. Coplanar circles are when two or more circles are in the same plane. So these circles could intersect, and you could have 2 points of intersection, like these examples here. The circles could maybe cross and just have 1 point of intersection, which would be the examples here. Or the circles could not intersect, and there'd be no point of intersection, such as this example and this example. And then concentric circles are when two circles and they have the same center, but they have different radii. So their radii or radius, they are different lengths. A common tangent. A common tangent is a line, ray, or segment that is tangent to two coplanar circles. So we see those blue tangent lines there, and we see that those lines only touch each of the circle in one spot. Those tangents do not go through the circle. So it hits here, and then the line hits here and here. So those examples would be common tangents. So let's draw common tangents. How many common tangents do the circles have? And then draw them. So let's look at A here. So I could draw a tangent here. I could draw a tangent here. But I could also draw some tangents in between these two circles. There could be one here and one here. So if I count those tangents, I know that I have 4 tangents here. B, all right, so I know I have a tangent on the outsides. And once again, I could draw a tangent right there in the middle. And so this would have 3 tangents. For C, I could draw a tangent on the outside, tangent on the outside here. However, I could not draw a tangent in between these two circles because they do cross. So this one would only have 2 common tangents. All right, so let's try this again. Let's look at 4. 4 is very similar to C here. So we could only draw 2 tangents. How about number 5? How many tangents could I draw for this one? I could only draw 1 because the one small circle is inside, and so I couldn't draw any other tangents around it. How about for number 6? How many tangents could I draw here? The answer is 0. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. So if I look at this example here, anytime I have a tangent and then I draw a line from the radius, or I'm sorry, the center of the circle to that point of tangency, it will always create a 90-degree angle. So this is important for questions like this where I can actually solve for R, knowing that this is a right triangle. And if we have right triangles, we can find sides of a right triangle using the Pythagorean theorem. So in the diagram, B is a point of tangency. Find the radius of circle C. All right, so if I'm going to use the Pythagorean theorem, I know that a squared plus b squared is equal to c squared. I'll call this a, so that is AD squared, plus my other leg is r, so I'm going to call this r squared, is equal to. Now this is where we have to be a little bit careful. So if I look at my hypotenuse, I see that it's made up of 50 from point A to the outside of the circle, and then r from the point outside the circle to the center. So when I write this, I need to write it as 50 plus r, and I am squaring that. Okay? All right, so let's simplify what we know. I can simplify 80 squared to be 6,400 plus r squared is equal to, now, 50 plus r squared. I'm going to rewrite that as 50 plus r times 50 plus r. Remember, squaring is just taking a number and multiplying it by itself. So I'm going to take my quantity and multiply it by itself. So now when I have this, I can FOIL. So let's FOIL this out. 50 times 50 is 2,500. 50 times r is 50r. R times 50 is 50r. R times r is r squared. All right. On this side, I can combine these together. 50r plus 50r is 100. So now I have 6,400 plus r squared is equal to 2,500 plus 100r plus r squared. All right, so this is a lot. We have a lot going on here, but what do we notice is on both sides of the equal sign? Well, you should see that we have r squareds on both sides. And what happens when we have r squareds on both sides? They cancel out. So that is very nice. So now I have 6,400 is equal to 2,500 plus 100r. So now I just have a two-step equation to solve for r. So I'm going to subtract 2,500 from each side. This gives me 3,900 is equal to 100r. So that means that 39 is equal to r. So my radius of the circle is 39. A tangent segment from a common external, that means outside, point are congruent. So what that means is that if we have a tangent from r to s and a tangent from t to s, that means that these two segments are congruent. Now, how I always remember this is that this looks like an ice cream cone. This part here is the cone. This circle would be the ice cream. So anytime you have an ice cream cone problem, we know right away that I'm going to set those two sides of the cone equal to each other. So here's our example. If RS is tangent to circle C at S and RT is tangent to circle C at T, find the value of X. All right, so ice cream cone here. So I know these two segments are congruent. So 28 is equal to 3x plus 4. So I'm going to subtract 4 from each side. 24 is equal to 3x. Divide by 3. 8 is equal to x. In our last problem here, I want to find the value or values of x. I have an ice cream cone problem here. So I know I'm going to set these equal to each other. So x squared is equal to 9. Well, I don't care about x squared. I care about x. So how would I get x by itself? Square root. Square root. So what is the square root of x? Well, we know that x would be equal to 3. But remember, there is another answer for x. It's positive 3 as well as negative 3. So there is one question like this on the in-class assignment where you're going to have two answers like this. So just make sure you put both the positive and negative answer.